So we have methods that can manipulate strings. I believe we've talked about them. Dot split will break a string up into a list. You can get len, pass in a string there, and len will return the length of the string. You can do the same with a list. You can pass in a list. You can get the number of items. If you want to step through a list, you can use the for value in syntax, or you can do the same thing for strings. So what is a method? It behaves like a function, but it's attached to a variable. So it's variable dot method. And we will learn how to write methods when we learn how to write classes. So we've seen that before. T.left, T.right, right? Using the turtle commands. And now we're seeing them with strings. S.split. S.is upper. S.is lower, and stuff like that. A method knows about the internal state of the object with which it is called. Well, I don't know if it knows about the internal state. What it is an object, is a collection of data, and then the methods that can act upon it. Like a turtle has some data in it. It's got an X position, a Y position, an angle that it's drawing, what color it's drawing, how thick the pen is, right? All that stuff. And then, so when you call dot forward, it uses that information to accomplish its task. So in Python, everything is an object, which is different from some languages like C and C++ and Java, where some things are called primitive values, where numbers are primitive values, and then there are lots of object types called classes. In Python, everything's an object. So absolutely everything supposedly has a method attached to it. Let's see if that's true. I'm going to create an int variable and see if there are any methods attached to it. I equals 1, I dot, type of I is int. Well, it is a class. So, int class Python. Now there's a whole bunch of operations and functions you can use on ints. I don't even know what conjugate means. I guess I've forgotten what a complex number is. I think it's a number that has an imaginary component. All right, here we go. Here's some methods that you can call in integers. Want to know how many bits it would take to encode a variable in binary? Well, you can call bit length. If you want to convert something to binary, you just do bin. That turns it into a string, which is a binary representation. So what's a binary representation of a 1? I'm going to go back here and call bin I. 0b, that looks funny, but that's just saying that it's a binary number. What about 2? Binary version of 2. Right? We've seen that before. A binary version of 15. Anybody remember what a 15 is in binary? 8 plus 4 plus 2 plus 1. It'll have all the bits set. So 14, how would it be different? We're going to take 1 away from it. So what are the binary numbers going to be there? 1's place, 2's place, 4's place, 8's place. You want to change 15 to 14. It was 1, 1, 1, 1. What's it going to be after that?
1, 1, 1, 0.
Yep, 1, 1, 1, 0. So binary version of 8. Wait, binary version of 14 takes away the last bit. Check out a few more of those while we're on the topic. Bit length. Let's find out the bit length of 15. It ought to be 4, as far as I know. So if I is equal to 15, and I dot bit underscore length, 4. Takes 4 bits to encode 15. How about 255? That'll be 8 bits, because that's the maximum value that a byte can hold. This looks like a function, but it's a function that's attached to a piece of data, so it's a method. You can check to see if a float is an integer by calling .isInteger. F is equal to 1.0. Let me close this and open it again so that it's up at the top of the screen for everybody to see. Right, so F is equal to 1.0. But is it really, could it be an integer? Let's find out. F dot is underscore integer. Yeah, could be. F is equal to 1.1. Could that be turned into an integer? F dot is underscore integer. Oops. No, not an integer. Couldn't be converted cleanly. You could convert it, but it would round down. Or not round down. Yeah, it would round down, because that's what int does. If you round it, it'll go up or down. But if you just call int on something, it just drops all the bits past the decimal point. So the 0.1 gets lost and it leaves it as 1. You can view a complete list and documentation of methods by doing dir followed by the type. Like I didn't have to hit Google just to get a list of everything in the integer class. I could do that, and boy howdy are there a lot of them. The ones with underscores are usually the things we're not going to call. They are representations of other ways of calling them, like the POW function. Let's see what POW could do. I guess I need to actually create a file so that I can start doing this. A is equal to 1, A dot underscore underscore POW, and really this is just playtime. If we take 1, let's make it A is equal to 2, and we're going to raise A to the power of 3, and then print A. If I've got the syntax right, I'm expecting it to print 8. I believe we're on P. All right, and so print it out. 2. Oh, because I did not do A is equal to A dot underscore underscore power. Now that is a long way to go to just type this. That is the equivalent of A equals A star star 3 or A star star equal 3. So behind the scenes, star star is actually calling this function. That's the kind of stuff that the underscore underscore methods do. It attaches all those things to that data type, and then the operators can call those functions. So there will be a, whoopsie. To the directory of the int type again. Add, right, because we have an add operator. And there'll be a multiply. And stuff like that. And there's a whole bunch of other ones. Round, size of, what else? Like if you wanted to convert something to a string, there's an easy way, and then there's a more difficult way. A is currently an int. I want to convert it to a string. Here's how I could do it. That'd be the easy way. Or I could have done it the hard way. A is equal to A dot underscore underscore str underscore underscore, like that. And then when I print A out, it's going to print it in string form, so it's going to have some quotes around it. No, it's not. Oh, I raised it to a... I took A and I cubed it, and then I cubed it again, so it wound up being very, very large. That's why it's such an astronomical number. All right, so it converted it to a string. Big deal. I'd rather do it that way than do it that way. If you want to know something about a specific method, you can do that. You can use the help function. We saw a whole bunch of different methods attached to say, let's get the directory of the string class. Whole bunch of them. Oh, here's one. Ends with. That's kind of cool. How about .index? Or make trans? Or partition? I have no idea what partition does, so I'm going to type help str.partition. Help parentheses str.partition. Search for the separator S and return the part before. The separator S is not found. We can try it out. No, we're not. I'm not going to talk about it. Sounds like it does split, except getting the first part of it. So this is very useful. If you don't remember how the .split method works, you can do help str.split. So say we have a file name and we want to pull the file name and the extension out. We can use .split and we can split based on the period. So if our file name is myfile.txt, then when we call .split on it, which looks kind of funny, it looks like a frightened face, passing it a period, then we get it separated into the file name itself and then the extension. And if you recall, if you use the subscript of -1, it gets the last piece of data rather than the first in the list. So I'm going to play with that just a little bit. So our string, our file name, I'm going to use forward slashes, even though we like seeing backward slashes, just to make them easier to see. Because otherwise I have to do double slashes, and that really looks foreign to us. Unix, Linux, stuff like that uses forward slashes, so I don't feel too bad. temp/dir.txt. Now I'm going to turn it into a list. L is equal to fn.split, and I want you to split based on forward slashes. When I say forward, I mean on one underneath the question mark. And I'm going to print the list out. All right, so we got the drive letter, we got the directory, and we got a file name. Now that's not going to strictly, we can't just say, yeah, we probably could. If we were sure of that, we could say that that was going to be the drive letter, and we could say that the last one was the file name. However, figuring out what all the directories were in between would be an interesting little problem. It wouldn't be too hard, but I don't want to go too much in it. So let's get directory. Nope, that's a bad term for it. Drive is equal to list. How do you get the first element out of a list? What's its subscript? What's its index value?
0.
Yep, 0. And then let's get the file name, the file itself, and it's equal to, how do you get the last one? Well, we could say 0, 1, 2, but then if there were more directories, it would no longer be at position 2. And that's why they threw in the -1 as an index. So I can print the drive, and I can print the file. Right, and we get that, ignoring all the directories. What if we wanted to see if the file name had a period in it? Anybody remember the way that you can check to see if something is in something else? Like an if statement. If, and I want to see if a period is in that file name. What else could I do? Yep, the word in. We could split it up and then pull out the file extension. File list, name list, name capital L is equal to file.split based on the period, and I'm going to get the extension out. It's the second one, so again it's going to be -1. ext for extension is equal to name L dot split. No, wait, name L subscript -1. And then the file name will be the first part. The name of it itself I don't like using variables that are this closely together. Name is equal to name, subscript L, 0. Get the first part of it out, and then I could print out the name and then the extension. Yes, sir.
For name L, but yeah.
Yep. I goofed that one up. What do I need to do to correct it?
Parentheses.
You know. Well, it's already got parentheses, but I know that you meant to say quotes. Right.
I meant, yeah.
Right. There we go. And so it broke it up into a file name and a txt. So that's element 1. That's element -1. If we wanted that one, we could call it element, that's element 0. This is element -1. And we could get to this one by saying 0 plus 1 is 1. Or we could even call it -2 if we wanted to. And that would make that -3. But that's kind of silly. So, or you can count this way. 0, 1, 2. Similarly, we had something with 2 items. That's element 0. We could call it element 1. But we're guaranteed to get the last element if we call it -1. Start counting backwards from the end. So text files. What's a text file? It's a file containing ASCII text. If we viewed it with hex edit, when we looked at this column, it'd have a whole bunch of words that we could actually read. Hex ed.it. Upload a file. I'm going to pick a text file. And there we go. Here's some text. That looks pretty weird. I'm not sure about this class.a business, but we see some ASCII text here, right? You have to create an instance before you can blah, blah, blah. I can open a Python file, because a Python file is a text file. There we go. A is equal to 2. A is equal to, this is just the file that I just created. It looks like A dot underscore power, parentheses 3. So this is just a file that we were looking at. We can see that spaces show up as hex value 32, ASCII value 32. Character turns show up as ASCII value. There should have been a character turn somewhere. 0D, 0A, that's how Windows encodes character turns. It's a character turn line feed. 0D means go back, and the 0A means go down a line. Unix and Mac don't put the 0D, they just put 0A, and they assume that if you're going to the next line, you're going to return all the way to the beginning of the, you hit enter, it's supposed to go to the next line and scroll down one. But Windows did not assume that when it was created, which is a weird idea, right? If you had a whole bunch of text and then you send it back to the beginning of the line, then you'd have overstrike. That'd be pretty weird. I'm not sure how you would represent that on a screen. On one of those old dot matrix, on one of those old daisy wheel printers, right, it'd just print that line and then it'd come back here and overstrike it. Like if you wanted to underscore everything on it. That'd be some way to do it. So that's what a text file is. We can create text files really easily. So why do we care about files? Why do we care about files at all? Because you like for information to be saved from one run of the program to the next. Back in the old days, you had your Nintendo games, and you'd play, and you'd reach, and you had to stop. You turn the machine off. You turn it back on. You just had to start from the beginning again. You type in a research paper. You print it out. Then when you close the application, you'd really like to have the research paper saved to disk so that you could open it again and print it again or edit it. So it makes the data persistent. The data set could be much larger, right? We could read in 1,000 lines of data, or the programs that, calculated the census. There's 300 million people in the United States or whatever. You might have 300 million records in your data. Much larger data set. Read it in much more quickly than a human could type it, with less chance of error. It can be used repeatedly. We could run that census data and figure out, how many people live within within 100 miles of a major city, and how many people live in the zip code and stuff like that. You could use the same data set over and over and over. So we can create a text file using idle or notepad or text edit. So a text file containing floating point numbers, right? We just type in a number and we leave in a space, and we type in another number and we leave in a space, and so on. So if you feel like playing along, and you don't have to, go ahead and create a notepad file, notepad, and save it, save as, stick it in your favorite directory and call it import.txt, because we're going to bring it into Excel, import.txt. All right, so I'm going to put some column headers here. This is the cost, comma, and this is the quantity. Now the cost of this item, we ought to have a name, right, as our first column. So quote, name, end quote, comma. I'm going to put some spaces here to make it really easy to see what I typed there, but then I'll probably remove them. Just want you to see that. And I'm going to make these whole numbers just to make it really easy to see. So the name of this one is bread, end quote, comma, and bread costs $2 a loaf, and we want 6 of them. And then milk, end quote, comma, milk costs $4 a gallon, and we want 1 gallon. And we could keep going. Why am I putting quotes around these? Because I'm wanting these to represent strings, and I'm wanting these to represent numbers. And I'm not actually sure that Excel is going to require that. So we will find that out pretty quickly. The real reason for putting strings around it is so that you could put in things that had more than one word, right? Like wheat bread and whole milk. We want to do that so that this will be treated all as one piece of data when we import it into Excel. So these are going to be our column headers. And then the next row is going to have a line of data, and the next row is going to have a line of data. Now I'm going to save it, and I'm going to launch Excel. And they keep changing the way this looks. Open other workbooks. Open something from this PC. Find my favorite directory. See, they make it 20 clicks where it did not used to be that. But I'm going to have to change its data type that I'm opening from an Excel file to a text file. .txt. What is a .pm file? I don't know. CSV stands for comma separated, which is actually what our data is. So we could have called it .csv, but Notepad saves everything with the extension .txt unless you specify something else. So I'm going to choose text files, and there's my import.txt. And I'm going to open it up, and it's going to say, oh, by the way, this is a delimited file. It's got delimiters of commas. That's the separator. You can pick a different delimiter if you want. You could use slashes or tabs or spaces or whatever, but if you use spaces, I'm not sure what it would do with the stuff inside the quotes. Or we could have created a file where everything was of a fixed width, right? The first data was always 8 characters. The second column was always 2 characters and stuff like that. But this is delimited by commas, so I'm going to go with that. My data has headers. That is actually true. We see a header column. So I'm going to click that. Now I'm going to click Next. This is not delimited by tabs, it's delimited by commas. And here we're getting our data preview. The name of the item, the cost of the item, and the quantity. I'm not going to give you an exam on how to import something into Excel. I just want you to get the concept, because you can create your own .txt files with Python or some other programming language. It could be 1,000 lines long. You can suck it up into Excel and treat it like a spreadsheet and draw your graphs and stuff like that. Alright, so this column is text. General would work, but I'm going to say it's text. That one is just numeric, so I'm going to leave it as general. As a general type. And so is that one. I'm going to leave that. And I'm going to click Finish, and there's my flow chart, right? And now I could do stuff with this data, right? I could calculate a total cost, which is equal to that times that, right? And yeah, that equals that times that, right, and then I could copy that and paste that, and there we go. Right, now our spreadsheet has got that, and we could create a sum down here at the bottom, which was the sum of all the total costs, if we were spreadsheet gurus, which I really am not. There we go. Right. Okay. So we took our data, and with some minimal manipulation, we were able to bring it into Excel, which is pretty cool. Well, maybe we want to create a file like that out of Python. Well, we'll see how to do that. I believe that what they show first is reading from a text file. We might read from our import file, or we might just create something else. But anyways, when we write to a file, everything is a string. So if we try to write a number to it, it's still a string. And when we read in from it, we're reading in a string, and if we want it to be an integer or float, we would have to call int or float in order to get to it, just like what the user always types in. Write a print statement. Everything you see is a string. It may not seem like one, but if you print out 3, you're going to see the letter 3, which is ASCII text. You're not going to see a binary representation of 3. So data can be output to a text file using a file object. So let's create our own import file. We're going to import a file that contains some data that we're going to create, maybe with a for loop. Fastest way to generate some data. All right, so completely unindented. We need to create a brand new file. What was their favorite way of showing what it was going to be called? Okay, good old F. Single letter file names for the win. F is equal to open, parentheses, quote. We're going to give it a output file name, what we want to save it to. I'm going to call this one import2.txt. I don't want to overwrite the file that I already created. Comma. And then the next thing, whoopsie, get lost, is going to be the mode that we want to open it for, reading or writing. If that was an R, it would be for reading the file, but it's a W, so it's for writing the file. Quote, W quote. Now we have a file. Hopefully. It could mess up, like if we pick a drive letter that doesn't exist, drive letter Y. Oh, we really do have a drive letter. Y. Do we have a drive letter for everything? How about Q? Yeah, okay. So if we tried to open Q : / import2.txt, that would not work. Let's write something to our file. F.write, and we will write out some string. F.write, parentheses, quote. How about number, comma, and then square, end quote, in parentheses, end quote, in parentheses. Now we're going to write a for loop that just writes out 10 or 100 numbers, and they're squares. Number to the power of 2. So for x in range, starting at 0 and going up to 1,000, so I got to put 1,001 there, and I want it to increase by 1s, and that's really too much typing. I could have just done range parentheses that, and it would have defaulted to starting at 0, and it would have defaulted to going up by 1s. I just kind of like reinforcing that syntax. All right, we're going to do f.write. The string version of x, so str, open parentheses, x, close parentheses, plus a comma to separate our two values. Let's put some spaces here to make that easier to read. Plus the str of x to the power of 2. Str parentheses, x star star 2, close parentheses, and now we need one more close parentheses to fix that, to match that. So f.write parentheses, str parentheses, x in paren, plus quote, comma, quote, plus str, parentheses, x star star 2 in parentheses, in parentheses. This should print out 0 through 1000 and their squares, all separated by a comma. Then we're going to close our file with f.close. And I forgot something. I'm going to show you what I forgot as soon as... I'm going to go ahead and run this and show you what it does. I left something off that I'm going to have to add. And it would have been nice to have some message that said that I had written to that file. I should have thrown in a print saying that I've written to a file so that you would know what I was writing to. But let's open that file. You don't got to do this because it's wrong. But here's what our data looks like. I'm going to change it to open a text file rather than a Python file. There's import 2. And boy howdy, I'm not seeing a darn thing. But if I opened it in Notepad, would I be able to see it? Let's find out. Then I'll show you what I did wrong. And what I did wrong is I didn't put a character turn on the data. So, you know, if we viewed it unwrapped, well, I'm surprised it even looks like this, right? It just went off the end. And here's what I wanted it to look like. And that is not what I got. So I need to add to my printing. And I should just modify this statement to have a plus on the end and print out the new line there. Or I could do an fwrite, parentheses, quote, backslash end, in quote, in parentheses. Got to put the new line after every line of data that I write out. Otherwise, it just runs off to the end, and you saw that. I'm going to go ahead and put a message that said data saved to, and then I'm going to write out the file name. Well, this was kind of lame. I hard-coded that file name. I should have asked the user what file they wanted to write to. Let's get the file name. fname equals input, and I put this above the open command. fname equals input, parentheses, quote, file name equals question mark, or how, we could have just put enter file name, colon, space, end quote, in parentheses. And here where it says import2.txt, we're going to replace that with the file name variable. And I always lose somebody when I start changing lines. So take a moment to see what I'm changing here and putting in fname instead. Import2.txt, we're deleting the whole thing including the quotes, and we're putting fname there. So I just changed that line. And I want, well, they knew what they opened, but it'd still be nice to display a message. Print data saved to, end quote, comma, fname. Enter file name. Import2.txt, data saved to import2.txt. I could go and import that into Excel the same way that I did the other one. File, open, from this PC, my documents, CIT, import to, and it's going to do the same thing. It's going to ask me for some information. This one is delimited by commas, that is correct. My data has headers, and I made one more mistake up here, right? I forgot to go to the next line after I printed out the headers. I should probably fix that. So when we see our Excel document, it's not going to look quite right. And in this case, what is our delimiter? It's certainly not a tab. It is a, don't know if you can see them, what did we make our delimiter, the piece that separates each number? Comma, yeah. So let's do that. And there we go, right? Printed out all the numbers and their squares. Sure would have taken me a lot longer to type all into Excel. And our graph, right? Woo, we are awesome. We did that in 1 minute. We just got a raise. All right, let's close that. So that's how you save to a file. What am I going to have to do to fix this so that I go to the next line after I print out the header line? Well, this is the header file, right? I mean, that's the header line. So what am I going to have to do to fix that?
Add a backslash n.
Yeah, just putting a backslash n is good enough here. So now we have changed that line as well. I don't really need to run it and test it again. I'm pretty sure that works the way we want. Now what if we want to open that file and print it out in Python rather than in Excel? Really, you're not going to be using Excel that much, but I did want you to get the idea of saving the file, making the data persistent so that you could open it in more than one program. Let's open it for reading. We could just ask for the file name again. Fname equals input, or I could reuse the same file, right? Parentheses, quote, enter file name to read, colon, space, end quote, in parentheses. Now I'm going to kind of rewrite this, revisit this business of f is equal to open, but we're going to open it for reading. So inside the little quotes here, we're going to put an R. And instead of calling dot write, we're going to do something else. F equals open, parentheses, F name, comma, quote, R, end quote, in parentheses. There's a slightly different syntax for doing this too, which I believe that we will get to in a little bit. It's using the with keyword. We'll get to it. All right, let's read all this data. For every line in the file, for line in F, colon, print F. Let's not even split it or anything. We're just doing this really crude. And then let's close our file. F.close. Now this is going to be annoying because we have to enter the same file name each time, so I'm going to just start entering single letter file names. Excuse me. Right. So enter file name. Y. Data saved to Y. Enter file name to read. Y. And woo-wee, that didn't do exactly what I wanted it to do. So I must have messed my syntax up. It's fascinating. Why does it show that? When in doubt, go back to the PowerPoint. So the file method expects a string as an argument. So we had to create a string. That's why we did all this plus, plus, plus stuff. We could have made that even a little bit more clear. You don't got to do this, but if I cut that and put an S there, and then above this I did S is equal to all that, you're getting the idea that I had to create a string in order to get that to work. And I could have tacked on the new line right while I was doing that. All right. If that makes it clearer, if you want to arrange it like that, where you create a string and then you write it out, that's cool. Oh, here's what I did wrong. Imagine that I had this. List is equal to something, blah, blah, blah. I'm going to delete this stuff. And then I did for X and L colon print L. What is wrong with that statement? That's not what I want to do. Yeah, I want to print X. I don't want to print the list over and over and over. See, and so since F was our file, I don't want to print file over and over. I want to print out line. So I'm going to have to fix that line right there. I'm going to have to put line inside the parentheses. So I'm coming here and I'm changing this line to make it say line. That'll look a lot better. Enter file name T, enter file name to read T, and there's all the data in our file. We didn't do anything with it, but we could call dot split. Notice it's putting a blank between every line. That's because it's getting that backslash in. If we printed it out character by character and printed out the ASCII values, we would see that it was ended by a 10. It was ended by a backslash. We probably want to strip that backslash off before we processed it. So here's what I'm going to do. I'm going to do line, I'm putting this above the print, line equals line dot strip, parentheses in parentheses. And what does that do? Remove white space from start and end. White space could be tabs. White space could be spaces. White space could be character turns, which is what it is in this case. And you know what I mean by character turns. That's the line feed, the backslash in there. Each one of these pieces of data has got one of those on it, which is why we're seeing the blank lines, because when it gets printed out, we're printing out an extra slash in on each line. All right, inner file name T, inner file name T. And now we don't have our blank lines. We like that a lot better. So this is code for reading in a text file and displaying it on screen. I think I'm going to label it as such. Open file, read in, print every line, close the file. Let's see what happens if we try to save to a drive letter that doesn't exist. Did I confirm that Q doesn't exist? Q.T.Q :T.txt. Boom. No file or directory Q:, so we were unable to do that. Well, that's when we were trying to open it for writing. That drive does not exist, and so we got an error. It'd be pretty nice if we had checked to make sure that we could open that file, or if we caught the error. If we wanted to catch the error, you enclose it in what's known as a try-catch block. Excuse me, a try-except block. And I'm sure that I've talked about this before. Let's just demonstrate it. Try. F is equal to open, parentheses, quote, Q:// T.txt, end quote, end parentheses. Open it for writing. Now that's going to blow up. We're going to confirm that by putting a print statement here that said F file opened, and it's never going to get to that. So after that, I'm going to back tab all the way, and I'm going to put my except : just like when we were trying to catch errors converting numbers. Except : we're going to print an error message. Error opening file. Now this is kind of crude. We're not saying the file name, so they don't know what went wrong. We're getting to the point where it becomes a ridiculous amount of input each time we do it. T, do all that. I need to change that. And then error opening file. Right. It did not crash just because we entered a drive letter that was invalid. I might want to encapsulate this in a function that would only exit when we had successfully opened the file. So I'm going to go ahead, I don't know about deleting it. It'd probably be easier if I deleted it completely because we're going to modify this a little bit. So def space get file parentheses fname comma mode in parentheses : because we want a file name and we want a mode. We want to know if we're opening it for reading or for writing. And so we're just going to do a while true loop. Do this infinitely until we actually get it opened. While true with a capital T. Let's get the file name. All right, that was dumb. We don't need fname there because we're going to ask the user for it. So please modify the function header to remove fname comma. While true, fname equals input parentheses quote open what file question mark end quote in parentheses. Now we have a file name. Now we're going to try to open it. F equals open, parentheses, F name, comma, mode. If they send us an R, then we will open it for reading. If they send us a W, we will open it for writing. And if that works, we're going to return F. We're exiting our loop successfully. We could use a break statement. We've seen break statements with while true, so I think I'm going to change that to a break. But if there's an error, we want to print out that that file name could not be opened. So back tab one level, so it's in line with the while. Oh, I've messed up. I forgot to put my try. Sorry guys, I'm going to have to make a few changes to this. You see these three statements? We're going to have to tab them over one so that we can put a try in front of them. Boom. And then come to while true and do try, colon. And then except, and this has to be lined up with try, so back tab however many times you got to line it up in the try column. We're going to print out our error message. Print, parentheses, quote, could not open, space, end quote, comma, F name, in parentheses. Now I want out of the while loop completely, so I'm going to back tab 2 times. Add a comment just to help myself keep track of where things are. And I'm going to print that the file was opened. Still has to be lined up. I don't know why it went there. Print, parentheses, quote, F name, comma, quote, was opened, end quote, end, parentheses. And then we will return the file. Now we can call this anytime we want to open a file. And it would keep looping as long as they'd entered an invalid file name, which we can prove to ourselves. F is equal to get file, parentheses, and we want to open a file for reading. Quote, R, quote, in parentheses. That ought to be enough to prove the point. Let's get it going. Enter file name T. Enter file name to read T. Do all of our fun stuff. Enter file name. Open what file? q:/t.txt. Boom, we could not open it. It'd be nice if we said why, but so it was a bad file name or something went wrong. So I'm going to save it to t2.txt. Could not open that file. Why? Because we never made a t2.txt, but we did make an import, and an import2.txt, and it says it was opened. Now every file you open, you should close as soon as possible. It would be a programming error if I did not do fclose on these. It would be likely that I would not be able to open that T file for reading after I'd written to it if I did not call f.close. And you probably have seen errors like that before, right? If you do a file save as, but Word already has that file open, it ought to give you an error. File is already open, right? Rather than just overwrite it or, you know. If you don't do f.close, then the operating system has a lock on that file. You probably won't be able to copy it to another directory. A backup process, a simple backup process probably wouldn't be able to, you know, and if the machine was turned off at that point, it wouldn't have been saved to disk. So you always want to call .close as soon as possible. As soon as we're done reading to it or as soon as we're done writing to it. So whatever we were going to do down here, we ought to go ahead and close the file. But maybe there's something we want to play with from the PowerPoint, so let's go look. So you can open a file for reading with the open statement, pass in the file name, but pass in the quote R for reading. And just like range, if you leave off the first parameter, it assumes a default value of 0. If you do that, it assumes it's opening for reading. Now there are more than one way of reading data from a file. I think I said that wrong. There's more than one way to read data from a file. We've seen one way with a loop, just like our list loop and our processing a character loop, or our range loop. Here's how we did it before, right? We did a for line in F, remove the white space, right? So we just called for line in F and it processed it line by line, but we can also call .read. Here's our file that we opened for reading. So data equals f.read, parentheses in parentheses, and let's print our data out. Print F. Excuse me, I did it again. Print data. That read the whole thing in. Date, yeah. Print data. If you pronounce it data, you're a little bit more correct. Both pronunciations are accepted nowadays, but data is the name of the Android and data is the name of... Alright, so enter file name T, enter file name to read T. Now, it wants another file to read, so I'm going to just type in T again. And it read in the whole shebang. I believe so. Printed it out again. Yes, it did. So if you want to read the whole file in one fell swoop, you just call .read. If you want to process it line by line, you do the for syntax. That's worth putting in as a comment. When opening a file for reading, if you want to read the file line by line, which in my mind is what you normally want to do, use a loop, like for line in F, colon. To read the entire file with at once, use the .read method. Example, S equals F.read, parentheses in parentheses. Now .read will accept parameters that will modify its behavior. Let's do a help on file.read. So I'm going to pop open the shell again. Probably about time to go about. Make sure people are doing okay. Help file.read. I don't know what I'm doing. Ooh, file is not defined. It's not. All right. F is equal to open quote T dot, just that, for reading. No such file or directory. F is equal to open parentheses T for writing. Permission denied. Okay, fine. I'm not having as much luck using the help function there, so Python file methods. In fact, Python file read method. You can specify how many bytes you want to read. You only want the first 100 bytes of the file, you do f.read parentheses 100. Then you could read in the next 100 and the next 100 and so on, because it keeps track of its place in the file. It's not writing my file to where I expected. I'm not seeing. Okay, there he is. The T file is 12,000 bytes long. So I could call .read 12 times in a row, reading in 1,000 each time. Or I could call it, 120 times if we were reading in 100 bytes in a row, whatever. Read line reads in one line at a time, just like that looping. That's more useful than reading in the entire thing in one fell swoop, in my mind. So we could read one line of it. Data is equal to f dot read line. I just changed that line, and I'm going to modify my print statement a little bit to say first line equals, end quote. Definitely about time to see if, whenever y'all get stuck, please, you don't have to wait until I remember to go walkabout and help y'all. All right, so enter file name T, enter file name T, do all that stuff. I should take this out or make it a much smaller loop. Enter file name T, and the first line of it said number, comma, square. That's true. If you need to, you can rewind back to the beginning of the file with the .seek. You can also open a file for both reading and writing at the same time, which is a weird idea. But like you could read the first line of data, you could inspect it, and then you could rewrite it. So we could write a loop that would read the entire file. While true, colon, data equals f dot read line, parentheses in parentheses, print data. Now I'm being sloppy. I'm not calling strip to remove the new lines at the end. I'm expecting this not to work. I'm expecting a blank line between every piece of data. You know what? I'm going to change that 1,000 while I'm thinking about it to something smaller. Control F, look for 1,000. I didn't see it because it was 1,001. I'm going to make it 101. I'm tired of seeing all that output. You don't got to do that, but if you want. And there. We saw, ooh, and it's going infinitely. I've entered an infinite loop. That was not quite right. I did something wrong. Probably I am reading in something that looks like a blank line. So I might want to check to see if I read in a blank line and stop there. Well, we could do that. If len parentheses data in parentheses equals 0, then it's bad data. Quote, break. And there's a more elegant way of doing this. Just kind of hacking it to get it done as fast as possible. We've read our data in. Why don't we strip it? So data equals data.strip parentheses in parentheses. Now this actually is going to stop at the first blank line rather than at the end of the file because I'm doing that. If I left this off, it would only stop at the end of the file because every line is terminated by a new line. T, T, T. Okay, and it did successfully print out every line in it a second or a third time. To me, doing it the way I did it before, which was this, for data in F colon data equals data dot strip and then print out the data. That was an easier way to accomplish, right? We did it in 3 lines rather than 7 to accomplish the same thing. So this is the same. The above code is the same as what we demonstrated previously. All right, so here's what our homework assignment is going to be based on this. Write code that will use a while true loop that will, 1, ask the user to input a sentence. I've made it a little bit too complicated. I mean, not complicated enough. I need to come back and modify this. Here's what the file is really supposed to do. The program is supposed to do. Ask for a file name. open that file for writing. Open that file name for writing. We've done that before. And then use a while true loop that will ask the user to input a sentence, and then use .write to write that sentence to a file, to the file. And in 3, you better .write a new line after it as well, or else it's going to write it all out to one line. When we ask the user to input a sentence, if they had typed in the word stop, we're going to break. So for if the sentence that they typed is equal to the word stop, then break. So you get the idea. It's going to ask for a file name, t.txt. It's going to open it for writing. And then we're going to use a loop. It's going to repeat infinitely until they do that. They're going to type in a sentence, right? Hello there. They hit enter, it writes hello there to the file, followed by a /n to go to the next line. And they type in, you type in, my name is Joe. It writes that out to the file, along with a line feed. Then you type in stop. It writes out stop. This if statement should really be between 1 and 2. It breaks out of the loop. So after that, we need to close the loop. Excuse me, we need to close the file. And I could write this up as pseudocode to make it a little bit easier to follow. Then, open the file for reading. Use a for loop for data in file loop to print the file line by line. Then close the file. I thought we would be done with chapter 4 today. We didn't quite get there. Yeah, we got real close. We've done open, we've done close, we've done write, we've done read, we've used .read line. The only thing we skipped is how to read into directory structure. However, we know that we can open a file with a file name, c:\/ or slash my documents / t.txt. Just like that. Child / myfile.txt. If we have a directory called child, it will open it. Please tell me I got this going. But sometimes we want to make sure that that directory exists. Okay, we got all the way through it except for the last 5 slides. So I'm going to go ahead and ask that y'all do the quiz. I set a due date for next Monday, but we haven't done the last 5, so if you want to wait until after, well, that won't really work. Today's Tuesday. Yeah, so we're going to have a Thursday lecture, so we'll have one more day to lecture, over the last 5 pages on this. So over the weekend or something, get the quiz done. Or go ahead and do it before Thursday if you think you can read the chapter, which I know you can, and go ahead and answer the questions anyways. All right. So this does need to be turned into pseudocode to be a bit easier to follow, but let's go ahead and stop. Homework make sense?